Hey guys, Bukulate here. I'm going to give you a video. Yeah, again, I was just watching some of the tools today, and, well, currently we're getting smacked across the face with some sort of a disturbance. And guess what? It wasn't predicted at all. I see I don't know, any reason for us, as far as the tools that they let us see, to show that we should be getting any kind of disruption in our magnetopause and magnetosphere, especially to this level. And what I got you here, guys, this is the Enlil historic and predictive tool that they use to predict space weather. Basically, density and solar wind is what this is showing. And I've explained this before, but I'll do it again. Earth is the green line. Okay, up here is the plasma density, and this is the solar wind. Call it radial velocity, but that's solar wind. That would be the conditions at Earth. Okay, now the red line here is stereo A. All right, the red line, like I said, is the conditions at stereo A. It's important to know those kinds of things because conditions are going to vary, obviously, throughout the solar system. So we need to know what conditions the satellite observatory is actually having so we can, gauge what we're actually seeing. Again, if you guys look over here to the spiral graphs, actually, I'll zoom in real quick. Okay. Obviously, we're looking from the top down, guys. Okay. So the sun is obviously in the middle. The Earth is here. This is stereo A. All right, so when we're talking about stereo A, we're talking about a side view, basically, of the sun. It also allows us to see what's back here. Like if there's a CME, we can at least see the angle from here, right? Now, I get a lot of questions. Well, what's this other one? Well, that's stereo B. Anybody that's new to this, that satellite, these two were put up there at the same time. Okay, they travel in this orbit at the same speed that the Earth is orbiting the sun. So in other words, their year is the same as our year. So they stay in the same position relative to the Earth. But they always look at the sun. Okay, they're not going to look at the Earth. I'm sure they could probably turn these satellites if they wanted to, but they don't. Stereo B was, well, most of us believe that it was shut off because it was showing too much stuff. There was a lot of captures. Scott had gotten some really good captures from it. Basically, really the first really good imaging of what we would consider the Planet X objects. Okay, I mean, this thing was, he called an orbit, man. I mean, that thing was transitioning the sun and everything. So, I mean, it was a really good capture. And so, with that, plus multiple others, okay, Stereo B mysteriously quit communicating. It went into some sort of a safety role or what have you. They said they lost communications with it, but they said they regained it and was able to communicate with it, but now there's no data coming from it, according to them. They're probably getting data from it. They're just not letting us see it. And the reason why is because if you think about it, guys, when we're talking about this Planet X object, this thing is, a lot of the best captures we get is when it's over here. Okay, when it's doing its orbit, well, let's just draw a picture of the sun right here. So its orbit would be, something, stereo A would be over here, stereo B would be here, Earth would be here, right? So its orbit would kind of be like this around the sun. Okay, so, and that's just a crude little thing there, guys. So stereo B would be seeing it back here. Well, we can't see that anymore. They don't have a tool over there or an observatory. They do, but we just don't get to see it. But anyway, back to what we're talking about here. I wanted to show you guys this because this is what they were predicting the conditions to be here on the Earth, right? So if we look at this, it's pretty much a straight line, right? Now, the density there, it's about at a 6. They do change these values I think they do it because they don't want things to look as bad as what they actually are. And the reason why is because, say that stayed at 2 and 4 like it normally does. So when this thing would spike to 7, 8, 9, 10, you would see a big spike like that, like almost like a heart monitor, right? So that would draw attention to it. So I think that they do this, not only does it save room and it's easier to actually plot it right here for them, but I think they do that to kind of downplay what the actual situation is. So anyway, with that being said, they do the same to the velocity down here also. But if you look at this, guys, typically this down here on the velocity, it usually stays, the graph actually usually is about like 200 to 400. And what I'm saying is, if you look at this right now, it's at 400, 600. So they're basically trying to, right here, they're showing if we didn't know what we were looking at, it would look as if the solar wind was low and it was staying low. Well, it's actually it's not really high. It's in a normal range there, obviously. I mean, it's not high at all, really, but it's not as low as what it would look on a normal day. So what I'm saying is that this is 4 to 600. So when we start talking about solar winds getting up close to 600 or 700, that's when we normally start seeing disturbances and stuff. We would expect to see disturbances on our magnetosphere. Okay, our magnetics would be getting messed with. And again, if the density up here goes up, also that can also cause it, and it definitely adds something to the party there. So what I'm saying, guys, is right here, if you look, they're not predicting any kind of spike in anything. Okay, so whatever conditions we had here on the 18th, they were expecting them to continue all the way through, pretty much through the 24th. They're not expecting hardly nothing. And obviously they can't predict like a CME or something like that, or a big flare. You can't really predict those things. You can see conditions coming and you might get a little bit of a warning. But trying to predict things out 5 days in advance is hard to do, and I get that. But even if you look at this, there's nothing here showing any kind of disturbance. So, and they have the opportunity to change this graph anytime that they want. So if they see a change, I'm sure it's as easy as typing in some data. And it's probably all done with a computer anyway. It probably does it on its own. So what I'm trying to say is that today is the 19th, so the conditions, as we're speaking, well, actually, this is closer to the 20th UTC right now. What time is it? Yeah, it probably is. It's like the day's just getting ready to turn over to the 20th. So, I mean, the conditions would be right here on the 20th. That's what we should be experiencing. Well, we're not. Okay? The density or the solar wind didn't really raise, but this is the other one. This is the ACE. This is really actually where the models get their data from, a lot of them. So if you look, the yellow line is the speed. Okay? If you look at this thing, it actually went down. Okay? And I'm going to show you a disturbance here in a minute, and then if you look at the density, look how low it's hanging. I mean, so why in the world, and this right here is a actual historic, what I mean by that is this has already happened. They're just showing you what happened. It's kind of like looking at an old radar type of thing, okay, or a radar that just happened 5 minutes ago. If you look at the time stamps down here at the bottom, you can see it. It goes from 0, 100 to 0, 100. That'd be the 19th to the 20th. Okay, and I took this capture just a few minutes ago, about a half hour ago. So, yeah, I mean, they're not showing anything here. So why? This is my whole thing. We can sit here and talk about this phi angle too, but we're not going to because that's a whole different subject. Okay, and that's the blue graph up here. I mean, I could do a whole series of videos probably on that. But when you see disturbances and it drops out and does all kinds of crazy things there's always, it's suspect is what I'm trying to say. But anyway, So what the heck are you talking about, Blue Kool-Aid, right? I mean, I guess I should have just showed you this from the beginning. But um, we're going to go over here, and I'm just going to run this through real quick. And, this is over at the ISWA site. This would be our magnetopause, our magnetosphere. This is where I go to see these graphs, okay, these tools. Now, what you do when you get here, and I'll run you guys through it, ISWA is the site. If you just type that in Google, you can find it real easy. Or you can go over to planetxnews.org, go about halfway down on the page, and there's a bunch of research links there to all the tools and stuff that we use to do this kind of a research and subject. And just click on the one that says ISWA, and it'll take you straight to this site. Okay, I can leave a link also. But right here, when you get here to this page, you hit the magnetosphere tab, and then I just know this from the beginning. I go to tab 9. Okay, and there's the 3 tools that we always look at. Okay, this is something that I just know that we need to do. I've done it so much I can do it in my sleep, guys. It's just, yeah. So what I'm going to do is I'm just going to take that back about, let's just do 100 images. That should get us back enough, I would think. That way it won't take so long to load, and I can load all 3 of them as I'm talking. So basically, guys, we're getting these disturbances, and I'm going to talk about a couple different little signatures that I've noticed that are actually, it's repeating now. So we'll talk about that a little bit. And it's basically, I think our shields are getting breached more and more. And I think that we're experiencing disturbances, and some of the stuff is actually starting to make it through. That's my opinion, and I'll show you why here in just a second. Not massive amounts of it yet, but it's just another indicator of how weak our shields are getting. Because the sun is in a minimum, and that's what happens when the sun's in a minimum. We get weak. The sun protects us from the sun, and I've said that a lot. So anyway, what we're going to do is we're going to look at this real quick, and I'll show you. I'm just going to run through this real quick because I got some still shots of it already, and we'll take this over here. Yeah, so, but yeah, got this. You see what happens there? So there you go. Boom. Okay, we got hit right there, right? Now, I'll back that up a little bit. You see how it was started right there? Now, what you're seeing here, the dotted line is the satellite line, okay? That's where most of the satellites are at. So when you see this pressure get pushed back into that's how far it's getting into us. It didn't necessarily make it through or get to the Earth's surface or anything like that, but some of it probably did. But when something gets compressed like that far, yeah, we need to look at it. So anyway, what's interesting about that is it started like that. Then this hit was actually strong enough that it actually bent the bow shock in. Like it almost wrapped it completely around our planet. So anyway, that was kind of an odd thing. We don't typically see that, but yeah. So if we do that, I'll just run this through on the slide bar. See, and I've said this a lot lately, when we get hit, guys, we compress, and then very shortly after, and this is also odd about this actually took a minute before we had what we call rapid expansion. We pushed back, okay? And so if you see those minutes clicking by there, you're looking at 23, it's 23:02 when that started. So and it took it all the way till basically right there, 23:34. Now, I've shown in the past, guys, that when we do this rapid expansion, like from right there, typically it's like 4 minutes and boom, we do that. Okay? This one took a half hour. So I don't know what the difference was. Probably just more energy coming this direction. So if you see that like that, I mean, obviously, guys, you can see that that definitely looks like something, we got some sort of disturbance there, right? So you're going to see that boom, rapid expansion. And it's amazing to watch the rapid expansion because that's what happens. Energy hits us. It's like having a firecracker in your hand, and then we push back, and boom, our hand blows open in all directions. Right? Boom. See that? Okay. Now, we'll go over here and look at these other ones. And these other ones, obviously, they're going to look a little bit more impressive just because of the way the tool is. It's the same things, guys, but it's just showing it in different visual. Okay. Basically, it's the same thing. It's not exactly the same, but it's close. Now, something I will point out here. You see the solar wind up here? Okay, that's what the solar wind is. It's indicative of the solar wind speed. It's kilometers per second, and if we were to convert that, and we'll do that here in a minute, I'll convert it to miles per hour so people can have a better understanding of that. But yeah, that spiked. I don't know why it did right there, but it did. Okay, now this right here is what we consider pretty much a normal type of signature. But you see it start getting a little crazy. These are directional arrows. This is the way the direction of the solar wind is actually traveling. Okay, so as we go forward, all right. See, this also kind of puzzles me. If you look at this, you see how it got really low pressure out in the front, and how it's actually kind of almost all the way open right there. Now our shield's out here, guys. Okay. So if it makes it past our shield, then it makes it even easier for it to get into us. So basically what I'm saying is we go from that. Now we got that big hit right there, right? Well, our solar wind speed really did not go up that much. Okay, so we start there. We'll just call it 330. And then it goes to 400. It goes to 525, obviously. And then, the big one, right? The initial hit right there, okay, that really, in my opinion, probably should have raised it a lot further than what it did. Now you can actually see it incrementally increase. The solar wind speed is what I'm talking about up here. Okay, it's at 700 there, and then and it goes on up, and it gets to that's 1060. That's about as high as at least this one's showing. Now the duration of this was actually kind of odd also. I've already talked about that a little bit, but if you look at this is a lot of, it bent our bow shocks in, but it's as if it kept that pressure on us for an extended period of time, longer than it typically does. Okay, because typically by this point in these captures, you would see almost what looks like a wave going through our bow shock. This is just a straight line, so that means that energy was constant. Okay? So if we keep going straight, keep going through that. Now you see how it's starting to break off there a little bit? Now I want to point this out too. This actually this is really what kind of bothered me about this whole thing right here. Remember I said out in the front how we're getting weaker, right? Well, if you look at these directional arrows, right in the middle, even all the way up to about the satellite line, you see an arrow pointing towards the Earth. Okay, I'll take you back here. See how far that's away from us there? Now, this is what you would typically see on a normal day, on a normal signature. You see these right here? There's nothing pointing that way. All right, so what I'm saying is that energy hit us right there, and as it's going through, watch this. Okay, it pushed back a little bit right there in the front. But then look at that. See how it switched back over? That energy's through our shield. Okay, this right here proves it. If you look right here, see how it's red right here? That's where it should have stopped. The direction of it flowing this way. And it didn't. See how it kept on going? And like I showed you just a minute ago, there was an opening, kind of like right there. So I don't know what's going on with this. That's what is really kind of disturbing me right now. I mean, it's not like to be scared or anything like that. I'm just saying. And then you see this. Okay, we're going to talk about this more in a minute. See that increase in heat? That just tells you that that energy did make it past our bow shock, and we're pushing back against it right here inside of our shield. Okay, the Earth's still trying to protect itself, and that's why you're seeing that heat increase right there. But some of that energy has made it through our shields right there, at least in my opinion. Okay, and you can see how it takes a spherical kind of shape around it. I'll just zoom in here a little bit so you can see that a little bit better. Okay, you guys can see how it takes that shape, because that's, the shape of our planet is an orb, right? So I mean, there you go. The magnetic field is going to be in that shape. So that's why it hits our shields are out here, right? But if it makes it inside our shield, we're still trying to protect ourselves, but that's why you see that shape, if anybody was wondering. But it's like it's hitting something, that energy's going around it, right? I mean, you guys can see that. So anyway, I wanted to bring that up. That's one of the biggest points I wanted to make here. And that's staying there too, guys. Okay. Now, you can see how it's starting to dissipate, because look at the solar wind up here, or at least what they're calling the solar wind. 363, right? That's pretty low. No, that's normal. I'll just put it to you that way. That's a normal number. Also, the arrow is no longer facing that way. So that tells you that disturbance is actually, starting to dissipate as we're sitting here talking. This is real time. Well, not really real time, but it's close to it. Now, this is the lines of, the IMF lines, or the blue lines, our connection to the sun, other celestial objects. The black lines on this are the pole cap lines. I'm not going to go into big detail on that right now. And then you got the closed lines, or the red ones. So what we'll do is, I just want to show you this disturbance here real quick. You can see how things just start happening. Okay, there's the initial whatever, and then we react, right? And I know that this looks pretty impressive, because it actually kind of is. Now, if you look at this, it's almost as if when you see the colors, like out in the front or anywhere on this, become pretty much the same color, that means that there's really not much push or pull against itself. Basically, there's nothing there, is what I'm trying to say. I'm not saying that there's no shield there. What I'm saying is there's not much of a fight going on there between the two magnetic fields, because it's not producing any heat or intensity or any increase in the energy. Okay, so when you have stuff like that, that's really not a good thing. Okay, when it's like that, I know it sounds ass backwards, excuse my language, but that's what it is. And this is what I'm talking about, a wave going through. You guys see that bubble going right through in the whole magnetosphere? That's typically what we would see in a normal disruption. But watch this. Okay? You see that hit, and then watch. And it stays like this for a while. Then it does its little bubble. Okay? So that means we took a hit, and it stayed on us for a minute, and then we pushed back. And again, guys, I know that this is more of an impressive looking visual, but this was a pretty decent sized hit. Okay, this wasn't something that was small, or I wouldn't even be talking about it. So with that being said, I guess what we're going to do here, guys, is I got some still shots here, but what was I going to show you guys? I was going to show you something else. Oh yeah, we'll go over here and we'll convert the wind speed. Okay. You guys can get on the internet and get any kind of converter that you want. It's really easy. They're all free. But they show us in kilometers per second. So what we want to do is enter the kilometers per second, which was about 1,050. We're just going to call it that. That's close. Probably a pretty good average when we took that hit. And it converts it to miles per hour. So I do that. And I'll leave a link to this in the description. So that computes to 2,348,783 miles per hour. Okay, I know it sounds like it's booking, right? And it is. That's fast. Okay. So if that was true solar wind, the sun's 93 million miles away from us. So you guys can do the math there. You know, it would take it, I guess, almost between 2 to 3 days to get here. So if you did that and you went back and looked at the sun 2 or 3 days ago, was there something that happened? Was there a coronal hole? Well, they weren't showing it. Okay, if that actually is what happened, because if they did, if they had seen it, or if there was a coronal hole there, guess what? It would have been on this predictive chart. Because when there's coronal holes showing, guys, these things, like right here, you'll see it ramp up. They adjust for that. Well, they didn't here. So where did that come from? Well, I'm going to show you where that came from. Actually, I did a video yesterday. Well, guess what? This is where that came from. Okay? What do I mean by that? Well, this is one of the Planet X objects, okay? It induced a CME yesterday. I did a video on this already. By the way, we had another CME pop off the backside like 12 hours later. It wasn't a big one. Again, this one wasn't that big. So, you know, but it did illuminate this object. What I'm saying is, guys, again, there is a third magnetic field here involved. And I explained this yesterday as far as the speed of things and how they can travel. I just showed you guys miles per hour in the solar wind. Okay? So if it wasn't solar wind, what was it? We can talk about cosmic rays. That's coming into the conversation now. Okay? I think Scott's doing some research on that. And he's coming up with some pretty good stuff there. And again, you know, things travel really, really fast magnetically. Way faster than 2 million miles an hour. Okay, so what I'm saying is we can get these disturbances from a magnetic field disruption. Okay, almost immediately. Almost that, I mean, it's close to, I'm not sure if it's exactly, I don't think, it's not the speed of light, but I think it's really, really, it's close. It's extremely fast. Stuff can travel that way. I have to research that. I'm making myself sound more crazy than what I already am. But if things are traveling magnetically, they can switch directions, they can change in intensity, they can change all kinds of crazy things, right? And I'm going to go ahead and explain this one more time because I think it's important, okay? This is the Earth. This is the Sun. Okay? Let's put E and S. So, the Earth has a positive and a negative pole, right? Well, so does the Sun. Okay, we're just going to put them here like that. I'm not sure which is which right now. Just so you guys know, the Sun has a pole flip every 11 years. That's when you start talking about sun cycles and stuff like that. That's really kind of what it is. But anyway, positive and negative attract each other, right? So, I mean, say we're connected here and we're connected here, right? Everything's hunky-dory. We're doing great. Well, you add that Planet X object, right? Well, it has a positive and a negative and probably multiple ones, okay? Because we can have multiple poles also. We do every once in a while on the Earth. Anyway, so you start adding those other magnetic fields involved. Well, then you start this, this becomes trying to connect to this and this at the same time. Okay, the negative goes straight to the positive. It's trying to, or if it's going to the negative, it's pushing against it. So, I mean, basically what I'm saying, guys, see how chaotic that gets extremely fast? Just by adding a third magnet? Because that's essentially what we're doing. Okay? Now, you can put 4 or 5 in there. I mean, because all the planets are involved too, but they're far enough out and things are established. Okay, so that's how we're in that dance anyway, and that's how we stay normal. What I'm talking about is something that isn't normally there. Or wasn't meant to be there to begin with. Or maybe it was, it's just we're not aware. And so now it's here, and we're having to deal with these disturbances. And they don't want to really say what it is, or they don't want to go into it. So, whatever, So anyway, I am going to run you through this here real quick, because this was fairly impressive little shot we got, okay? This is at the beginning of it, and I'll just run you through. Okay? And I showed you guys the time lapse there. But, so that stayed like that. And I mean, that's pretty crazy when it stays like that for that extended amount of time. And again, I already showed you guys, they were not predicting any rays in the solar wind. And we just took a big raise right there. We just took a hit. According to it, it was showing solar wind, but was it true solar wind? Okay? I don't think it was. I think it was a magnetic disturbance or cosmic rays or something like that. But it did not come from the sun. For to call it solar wind, solar means sun, right? So it has to come from the sun. So when we don't see it coming from the sun, we look to other things. All right? And that's what we're doing here. So we have to look at other things. And that we have to figure out what's causing it, right? I mean, that's what we do. And I know, and I get it. I really do. I understand how sometimes it's hard to, number one, understand what we're talking about. And number two, to actually kind of grasp it and hold on to it, because we're so programmed to think that something like that really shouldn't be happening. And it really probably shouldn't. This may be a very natural cycle. Okay, and I'll show you something else here real quick. This is the other model. You see this? And what we'll do here real quick, what I wanted to show you guys about this one is, if you guys look at the timestamp on this one, 2202, you see that massive, like, big disturbance? It's red. It's high. It's supposed to be high winds, right? That's 2202. This is 2209, 7 minutes later. How did it go from that to that in 7 minutes? It takes longer than that, guys. That's what I'm trying to say. So, I'll just show you guys this here real quick. Let's see here. Let's move that up there. Alright. Let's just back that off. Let's go to, where's my video? Is that right here? Okay, yeah, this is where I'm going to go. Alright. Now I'm going to hit play, and this is going to show you guys this other model. Okay? This is the same time frame I just showed you on the ISWA. Now watch this. Okay? It's going to happen real fast. Look at that. And then boom. You see that, like, boom, right back to normal? And then it happens again. What the heck was that? Okay, what would kill our solar winds like that quick? And it did it on both models. Okay, so it's not a model flaw. I guess it could be a data flaw in, if they're getting the data from the same place. I don't think that they are. They could be, I guess. I need to know that. I need to figure that out. I need to go research that a little bit. But yeah, you seeing that? I mean, and that's, again, I want to pause it right there. Okay, look at this. What was I just saying about out in the front? If you guys look out here in the front, see how that's a lighter color? That's showing you the same thing the other model just showed you. It's showing you the energy is getting through there. Okay, wherever that energy is coming from, it's getting through right there. Because you'll see it close up. Okay, see it closing up? That's how it started right there. Okay, and this is the pressure model. Watch this. There's hardly any pressure at all. And then you see boom, and then you get a second one. Watch. Bam. Look at that. Okay. Now, I'm not going to go into like the Nibiru subject or anything like that, but what did that look like to you? It looked like a wing thing, didn't it? I'm not even going to talk about that subject because that's just one of those things. But, yeah, this is the CME tracker, guys. Okay? See that? That's that CME. It blew off the backside. Okay, it did not come close to Earth, but if you guys watch, I'm going to pause it. If you guys watch it, well, I'm going to back it up a little bit. You will see this dotted line? Okay, what that is this is Venus. This is its connection to the sun. That's basically that blue line I was talking about earlier, the IMF line. Now you can see out here where the Earth's at, this yellow dot, we're connected too. All these planets are, okay? Plus the satellites are too, guys. It's all connected magnetically. You guys have, I want people to understand that. Okay, here's that Parker SP satellite. This is stereo B up here. Stereo A is down here, okay? I'm surprised I even know the locations of those. I must be looking at these things a lot more than what I thought. Anyway, we'll hit play. Now watch that IMF line. See it move and bend? That's what happens magnetically when we get hit with a CME. Okay? So, I just wanted to show you guys all that real quick. It's hard to explain something like this when we're being told that it's something else, and this is, I wanted to show you guys this real quick. Remember I was talking about this? Oop. Right here. There's that little opening I was telling you about. Talking about here just a second ago. This is right now. This is today. Well, about 6 days ago. Look. Okay. See all that right there? It's the same thing. Okay, and this one lasted for a while because I sent this screenshot over to Scott because we were talking about this. And it shouldn't do that, guys. There's energy getting through there. That's what that's showing. It's making it through our shield, our bell shock out there. Okay, and it doesn't last very long, and it's not really probably causing much. But just think about the GPS systems that went down over in Europe and stuff like that. When that thing gets inside our satellite lines, that's the kind of stuff that can happen. Please, guys, go research the Carrington event. Please. You'll have a way better understanding on what can happen when we get hit with stuff like this. When we get hit with a bigger flare. Okay, now, I wanted to show you guys that wind speed, okay? Because that wind speed really, at 1,000, yes, we should see some pretty decent sized disturbances, right? We should see some big magnetic disruptions. But when they're staying at 300 to 400 and we're still getting these big, like, signature mess ups here on the tool, it's hard to believe that it's just solar wind or an increase in ions or anything like that, okay? So that's why we talk about this, and I really truly think that third magnet is being, that's what's happening right now, okay? But they're trying to make us think that it's this. There's nothing going on. That's a straight line. Look at that. They didn't show any increase in the solar wind at all, but yet we seen that big, huge disruption. Well, then tell me where that's coming from. That's what I want to know. All right, here's that other model, and here's that first wave that came through. You see how intense that can get really fast? And again, it goes from that to that in like 6 or 7 minutes. But anyway, guys, I just wanted to bring that to you. I guess we could, well, you know what? I'll take you over to Siege real quick. And we'll take a look at, the CME that happened today and yesterday. All right. Now you're going to see this thing cut out about 1400. All right. It doesn't show any more images after that. You see a big bright flash. The tool itself may have caught some energy there. I don't know. But we don't get any captures after the 14th on the Siege site anyway. We could go over and look at it. Again, this is our view. Earth is kind of here looking this direction. So that thing kind of blew off this way. And it actually could have blew off towards the back. So I don't know. But if we go over and look at stereo A, you're going to see that. Okay. Now stereo A, the direction, the one I just showed you, okay, because Earth is here. Stereo A is here looking at the sun. So the CME I just showed you, these could be the same CME. I'm not for sure. Because if that CME was blowing kind of off to the back, and this is the Earth's direction, it would still kind of look like it was going off to the side. You guys can understand that. So this may not have been two different CMEs. It could have been the same one. I don't know that it was, but I can't say that it isn't. I tried to find it on SDO if we had any kind of capture there, and I didn't see anything big jump out at me. I'm kind of inclined to think these are probably the same CME. I looked at the time frames, but you know it's hard to tell because this Core 2 is really, really grainy. It's hard to, it doesn't give us a very good detailed picture. So that's why I don't show it a whole lot. There are things that we do catch on that, and I do look at it daily. But yeah, guys. Hope everybody has a good weekend. Where I'm at, guys, we're at a heat wave, extreme heat wave, heat warnings. I was out in it today. It was bad. I have to tell you that. It was bad stuff. But yeah, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.